Now I will go for the next class, because after completion of the column, then you have to place the beam. Beam is, in technically we will call as a framing. So a structural framing. A structural framing. So framing is the component which is loading all the stress and strain from the floor. So framing is nothing but it's a beam, structural beam. Okay. So in beam also there will be a types of beams. Types of beams. So let me know any of the types, tell me the name. Don't know any types? How many types of beams are coming in a project, any buildings? Don't know? Yes. Yes or no? No. So there is a rectangular beam. Okay, rectangular beam, square beam, okay, next, capital beam, capital beam? Capital beam also will become, then yes, cantilever beam also comes under rectangular beam only. And other types, joist beam, joist. Have you heard this word, joist? Joist beam. Gutter beam. Gutter beam, gutter. Any more? One more it is there, pan joist. Pan joist beam. So there are 6 types of beams we are going to design the projects. Okay, so first beam is rectangular. Rectangular means the beam it is going to be show as a rectangular shape, means here the slab is there, here the beam will become, and this beam is going to be show as a rectangular with length and width and height. So that beam we will call as a rectangle. See here this is the beam, and already I told you the beam height is always including slab thickness. So beam is equal to width into height. Height is equal to including slab thickness. Am I right? Slab thickness. Okay, so here the rectangular shape of the beam means width is different, height is different. That type of beam we will call as a rectangular beam. Square beam. Square beam means it will be look as a square. The width and height will be having the same value. So that type of beam we will call as a square beam. Here also we will consider here this is the width and this is the height. And capital beam is like that, the slab will be coming, okay, exactly the slab bottom there will be a like that, it will be there. So this type of beam we will call as a rectangular beam. Okay, directly here the slab will be there, that's all. Bigger size of slab means here the slab will be there, here the beam will be there. Capital, which is holding the slab. Some of the parking floors you can able to find this type of capital beam. The height will be very less. Here also this is the width, and the height here it is not taking up the full the slab height. It is only the bottom floor height. Bottom of the slab, how much the height will be there, that height is going to be considered for the capital beam. Here there is a joist beam. Joist beam means the beam will become like that. This type of beam we will call as a joist beam. Here also there is a width and including there is a height. But here we are going to consider some angle also here. And the minimum angle is 30 degree. 30 degree is the angle for the joist beam. And there will be a gutter beam. Gutter beam means it will becomes in steel structure. Here the steel structure will be there. Here the above there will be a MS sheet, and below we are going to put some I section gutter like that. Okay, and here there is a slab. So this type of gutter we are also taking as a width, and here the including this is a height. So this type of beam we will call as a gutter beam. And here one more, it is their pan joist. The beam is going to come like that. Small angle again, and this way is going to be considered. This type of beam we will call as a pan joist beam. Two steps will be there. So this type of beam is also will be considered. So here, from here to here, this is the width, and from here to here, this is the height, and here to here, this is the H1, height 1 also will be going to be considered here. So H1 how much, width how much, and total H how much. So here this is the, so H1 is the height of angle width. H1 equal to height angle width, height of angle width. Angle width it is going to become. So here there are 5 types of beams. So this beams is going to be look in a front view like that. But when you will draw this beam in a top view, here the column will be there. Okay. Here the column will become, and again here also the column will become. So column to column we are going to be put as a dotted line, and this dotted line is going to be indicating the beam size. If your beam size is coming some B1, and a bracket we have to write the value. So BM 450 is the width and 600 is the height. Like that the text they are going to be show in a beam. Okay, so like that the beam will become. Here this is a concrete, here this is a concrete. So column to column in between they are going to put the beam. So everywhere if he is having one more column here also, so here also one more beam is going to come. So it is going to be connect from column to column. It is going to be connect from column to column. Again here one more column is there. So we have to place one more beam also here. And this is a column. Again here also one more beam. Like that it will be come. So from columns to columns the connectivity is beam should be there. That we will call as a framing. But if you are going to cut this as in section view, how it is going to be look? It will be look like that. Here there is a column. The column will be there like that. And below there is a foundation. The concrete foundation will be there. Again here one more column. And there is a foundation below. Okay, and the beam is going to be look like that. So whatever the height we are going to consider, this we will consider the H, height of the beam. So if you cut the section, it will be look like that. Here also the column, and this is a beam. So this we will consider as a beam. Okay, so this way we are going to be design the beam. So always the beam will be, if you are placing the beam in a plinth level is ground level, that we will call as a plinth level. Some people they will call as a floor level also. But the beam which is coming in the floor level, that level we will call as a plinth level. And the beam if we are going to place in that level, we will call as a plinth beam, tie beam. Some people they will call as a tie beam, TB, and some people they will call as a plinth beam. Plinth is The ground level, when the beam is coming, that area, that level, whatever the beam is there, that beam we will call as a plinth beam, PB. They will consider as a PB. PB is nothing but plinth beam. Plinth beam. Some people they will consider as a TB. TB is nothing but tie beam. Remember, these both are same. But some people they will consider as a tie beam, some people they are considered as a. So whenever the floor height is coming more than 1 meter from the ground level, that time that beam we will consider as a tie beam, greater than 1000 mm. And if it is having less than 1000 mm, then it is plinth beam from ground. Both are beam, but only the height difference will be the less and more. Okay, so now in our Revit projects, our BIM projects, how we will place this beam? So there is an icon is there in structure, and you have to click the beam. So whenever you are going to place the beam, always you remember, because here the beam, the first this end we will call as a start end. Because the left end will be always start end, because when you are going to place any beam, we have to start from left to right, and here this is end. Okay, start and this is end. So start, left side is start part and the other side is length part. Like that it is going to be come. So here when we are going to place any beam, so we have to give start offset value we have to give, and end offset value you have to give. Both offset value you have to give. So whatever the offset value you have to give, always you remember, because what will happening when you are placing a levels, this is, you just remember, this is some level 1, and above there is one more level is also coming, that is level 2. Now your beam is coming exactly, because this level we are considering as a FFL. Am I right? This level also we are considering as a FFL. Okay, so the beam, slab, everything should become below only this level. So your slab will become below this level, because FFL will be having some height. So here this level will become, and here there may be your beam may become like that. Here also your floor may become like that, and in between your beam may become like that. So whatever the thickness of the FFL, if you are taking some 100 mm, so here the start offset you have to minus 100 mm, because always you remember your beam offset should be always FFL subtraction. So you just remember here the this as a formula, that offset of beam equal to, okay, step 2, subtract the FFL value. So if your FFL, how much it will be there, you have to subtract the value of that FFL value, because FFL exactly the beam will be not come, because the beam will become below the FFL, finished floor level, because your tiles or marble stones which you are going to place, it has to be subtract that value. So whenever you are going to place any beam in a project, any floor, you have to see what is the thickness of the FFL, and that thickness value you have to minus both end, start end and left start end, right end. Both end you have to make it subtract, because if you are giving one side value, what will happen, your beam will become as a slanting, it will become slanting. So like that, don't keep slanting, you have to give both side the same value. How much the FFL value will be there, the same value you have to keep in the beam both end. And whenever we are going to place the beam, always you remember your beam the first start point, you have to take the center point of the column, again the next column. Always you have to take the middle of the column. So middle of the column, we can say here middle of the column or intersection point of the column. Placement of beam. Placement of, placing of beam should be middle of column or intersection point of column. You have to take the placement. When you are going to place the beam, always you have to take the intersection point or middle point. Intersection point, any perpendicular point we will call as intersection. If it is coming a beam to beam like that, if it is coming here also beam is there, here also beam is. So this point we are going to consider as the intersection point. So everywhere when you are going to place the beam, you have to take the intersection point of columns or middle of the columns. Because what will happen when you will take the middle of the column, so exactly here some connectivity is there, connection. So the connection is going to be placed exactly, connection to column, connection to the column, it will become like that, it will be there. Okay, so each and every beam you have to remember in such a way that the placing should be always, while you are clicking the start point, while you are clicking the end point, it should be middle of the columns always, or intersection point of the column. Because somewhere what will happen, the columns will be not in a straight, it will be have some angle. So if it is coming in the angle, that time also you have to check with the intersection point of the columns, and exactly it will be placed the side by side of your project. So this way you have to place all the beams in a project. So if you are having ground floor, so ground floor, all the beams you have to place, first floor, second floor, third floor, like that. How many floors are there in a project? All the floors you have to place the beams in this way. Okay, because when you are going to place any beams, you have to remember these things first. Offset, placement, because if you are not placing correctly the beam, so there will be a gap between the columns and the beam. There is some gap will become, some 2 mm, 3 mm gap will be there, because it is not going to be connected properly. And that gap is going to be show all the area of the beam. Any floors, if you are going to take, all the floors, it is going to be show the same gap. So here all the beams should be placed in such a way that it should be connected with the columns. And when you are going to connect it here, one circle will become, and that circle we will call as a connectivity. Connectivity we will call. So all the point will be having a connectivity. So we have to go with the connectivity, and based on the connectivity you have to follow the same. Okay, so this way we are going to place all the beams in a project. Okay, clear? So this way we have to do the placement of the beam. So now I will show you how to place this beam practically. You just follow the same, and here in AutoCAD also I have given the drawing in the project. So in the drawing you can find there is a beam is there, and all the beams, all the floors you have to place in this way. Okay, so like that you have to follow the same.